Okay, so I'm going to walk you through how to solve for both kinetic and potential energies using the formulas we discussed so far. I'm going to do kinetic energy first in pink. So my formula for number one is E sub k equals 1 half mv squared. I'm going to go back and substitute in what I already know, which in this case is my mass of 25 kilograms and my velocity of 5 meters per second. Notice I'm using brackets and parentheses to keep the 5 separated, so we are only squaring that 5. My final answer for this particular question is 312.5 joules. I'm going to jump over to the right to number 7. And again, the first step I'm going to do is write out my formula. E sub k equals 1 half mv squared. Substituting in again what I know is my 0.15 kilograms for my mass, and my velocity in this particular situation is 100 meters per second. Again, putting that inside of parentheses and brackets to keep that number squared. My final answer for kinetic energy over here is 750 joules. Right underneath this, I'm going to go down to number 8, and I'm actually going to solve for mass in this example instead of kinetic energy. I'm going to substitute in my 96 joules. I'm going to keep my 1 half and my m, and then I'm going to put in my velocity, which in this case is 4 meters per second. Again, inside parentheses and brackets. There is an extra step in this situation, so 4 squared times 1 half is going to give me this 8 that you see me writing right now. And then I'm going to have to go ahead and divide both sides through by that 8 to get the m by itself. My mass is going to be 12 kilograms. Right underneath this one for number 9, I'm actually going to solve for velocity in this case. So again, starting off with the formula, E equals 1 half mv squared. And my kinetic energy is 1,125 joules. I'm keeping the 1 half, and my mass is 250 kilograms. My velocity squared stays in the equation, and then I'm multiplying my 1 half times my 250 to get to the 125 times my v squared. Again, I have to divide both sides through by that 125 to get rid of it, and I will then have v squared, which is 9. This is not our last step. We have to go ahead and take the square root of both sides to get the v by itself and get our 3 meters per second. At this point, I'm going to jump over to my potential energy calculations in blue, and my formula for this one is E sub p equals mgh. I'm again substituting in what I know from the problem, which is 150 kilograms for mass. My 9.8 meters per second squared is a constant, so that will not change in any problem. And then my height is 5 meters. I'm going to multiply straight across, and my final answer for this particular problem is going to be 7,350 joules. Right underneath it, I'm actually starting off on problem number 3 and changing my mind as you see me scribble it out in a second. I'm going to jump down to problem number 4 because I realized number 3 was a kinetic energy problem. So again, first step is always to write my equation, E sub p equals mgh, and then I'm going to substitute in what I know. My mass in this case is 2.5 kilograms. That 9.8 meters per second squared does not change, and my height is 300 meters. Again, busting out my trusty calculator, I'm going to multiply straight across to get my final potential energy, which for this problem is going to be 7,350 joules. Last but not least, I'm going to jump over to the right to number 10, and in this one I'm going to be solving for the mass. So I'm going to use the same exact formula, E sub p equals mgh, substitute in my 2,778.3 joules for my potential energy, keep that m, put in my 9.8 meters per second squared, and then my height of 12.6 meters above the ground. My second step in this case is going to be to keep that 2,778.3 joules, and then I'm going to multiply the 9.8 times the 12.6 and keep that right next to the m that it's multiplied by as well. So that's going to give me my 123.4 m here, and I'm going to divide both sides through by that 123.48, and I'm going to end up with a final mass for this particular example of 22.5 kilograms. Don't forget that when you're dealing with any of these problems, your mass must be in kilograms. It cannot be in anything else. And that your 9.8 meters per second for your potential energy situations will never change. That is a universal constant. Thank you for watching, and I hope it was helpful.